Sorry, just recap what you've done there. This is incredible. Just tell us, give us the TLDR on what just happened.
So the TLDR is that I took a Python function, I ran it 4,200 times. That was auto-scaled onto however many H100s it would take to consume those inputs without having to write a single line of YAML and with only a few extra lines of Python on top of the original code.
Amazing. What are we looking at, man?
Yeah, so pull up my VS Code here just because I wanted to give like a quick modal demo, just why is modal cool. I was talking a lot about hardware, about the machines that you need to use. We talked a lot about purchasing hardware and how that's difficult because, okay, do I need this amount of gigabytes now or in the future? We talked about scaling up things, being able to handle more requests or larger models. And these are all problems that actually Modal, the platform that I work on, helps solve. Modal makes it easy to take your Python code and run it in the cloud, to deploy Python applications. It's got a bunch of nice primitives, remote dictionaries, distributed file systems, like all this kind of stuff that you need, and GPUs. Let me show you what it looks like to run something on Modal. I've got a Python file, and I'm just going to use the Modal command line tool, Modal run, to run this script. The same way I might run a Python script locally, let me run this script on Modal infrastructure. So this is like spinning up a bunch of containers, I guess just one container, and running something on Modal, running in the cloud, getting me back a result. And it happened faster than I could even say what was going on. So then let's see, the nice thing about Modal is that it's not just, oh, I want to run one thing one time. It's like I have an embarrassingly parallel task that I want to run a bunch of. And so let's do print the square is X. Yeah, let's see. Let's make this a for loop. For X in square dot map range 42. So now I'm saying I want to run this function a bunch of times. This function that runs on Modal, and then I'm going to want to print the square is X. Yeah, okay. Format that, move it over. All right, print the square is X, blah, blah, blah. So like this function here is a regular Python function, nothing up my sleeves here. All we did was decorate it. This is decorators. Decorators in Python are like Python's version of higher order functions. They take in a function and return a function. They take a function and they give it some new feature. There's lots of decorators in Python. Modal's decorators are like, run this in the cloud. So that's what's going on here. And it's not just run in the cloud, but also make it possible to run in parallel in the cloud, which should happen now. We're running it 42 times. Oops, I thought I typed an F there. So we printed the square as X 42 times. That's even less compelling than the demo normally is in terms of its outputs. Let's run it 420 times. Now you can see 10 containers or so spun up to handle that workload. Maybe let's do 4,200, and I'm going to make it a little bit wider. Little bit wider there, so we can maybe see the outputs a little bit more. Great. So now you can see 4,000 inputs. You can see the containers are spinning up. It's stabilizing at about 20, 25, printing the outputs, printing logs and printing outputs here, all as easily as it would be to like run this script. And then lastly, for the PA state resistance, let's do GPU equals H100. And this is running on a remote H100. So now let's just do a quick NVIDIA SMI, as people like to do. Process.run NVIDIA SMI. That should be all I need to do. Let's run it. I don't need to make sure that the code is right because I can just run it and see whether it works, which is my preferred way to do debugging. All right, now we've got about 10 H100 containers, each printing something, squaring on the CPU and returning it.
Stop it. No, don't stop it.
I can't stop it. No, you can stop it if you want. And it'll spin right down, and you won't need to keep paying for it. You don't have to worry about, oh, did I spin up an instance, and is it still going, blah, blah, blah. It's serverless infrastructure. So you tell us the code that you want to run, you describe the machine you want to run it on, but you don't have to think about administration of machines the way that you do with a typical cloud infrastructure like an AWS or GCP.
Totally. And of course, this was a toy. Sorry, just recap what you've done there. This is incredible. Just tell us, give us the TLDR on what just happened.
So the TLDR is that I took a Python function, I ran it 4,200 times. That was auto-scaled onto however many H100s it would take to to consume those inputs And yeah, all without having to write a single line of YAML and with only a few extra lines of Python on top of the original code.
Amazing. I was so sorry. This Michael Liu, you're so funny. But Michael Liu's just commented, bro is trying to take AWS's lunch money, which I really
We like Snowflake is like a similar situation. They make analytics SQL really nice on top of clouds. And the thing is, they pay AWS a bunch of money to use their cloud infrastructure. We have a
Yes.
similar situation. We're using cloud infrastructure and like making it useful for people. If I were Jeff, I wouldn't be that mad that somebody's found a new way to get people to give AWS money through us. Yeah.
Not at all. I'd consider acquiring at some point. I do. I joked about developer ergonomics before, but the API and the use of decorators, chef's kiss, my man. I know we've got to jump out in a minute, but that was a toy example. Could you just run us through some other examples? I love the examples on your website. So if you could run us through those. What just before you do that, while you show your screen, I do want to say, so you do have a free tier, but you also are very generous with credits for open science and all of these types of things. So if you could show us some of those examples and show us what you do for science as well, and if people can get free credits, that'd be awesome.
Yeah, so we sponsored a team that got second place on ArcAGI Pub that just recently. So that was the like MIT Cornell team. Yeah, so we do a bunch of those kinds of one-off academic projects. So if you got something, it's important to us that you open source it because we're a platform company. And so we aren't like our stuff gets more valuable the more people can do with it. And so the more people like build software, the like better for us. So there's like a nice alignment of incentives between us and like academics and open source people. So that's where I see this coming from, and that's what I use look for in people that we give these grants to. We also have like a startup program that's a little bit more directly transactional, where we'll give you some compute credits because we think you'll like the platform so much that when your startup blows up and you get to the scale of Suno, the music generation company, you'll want to run all your inference on Modal.
Very cool.
And
And
yeah,
so
so that
Suno uses Modal?
yep.
Super cool. Suno cool. Okay.
So
Let's have a look at some of
credit
your other
stuff.
featured examples.
Yeah, so this year, the best way to get started with Modal, it's a pretty complex product because it's building a novel computing platform. So there you can dive into the references and grok it from there. But I think the faster path is usually to find something relatively similar in our examples and jump from that. So I maintain the examples. I try and make them state of the art as much as possible. And also they're monitored for correctness and continuously integrated and tested. So they should work, and they should teach you the right way to use Modal and the right way to use tools. So just to give some examples of that, OpenAI compatible LLM inference with Llama 318B and VLM. This is fairly recent updates. It's got the like machete kernel 4-bit quant of Llama 3.1 from Neural Magic, just because that's a great small model to get running with. So then yeah, fine tuning. We have a Flux One fine tuning example. This is my former roommate's dog, QWERTY. This is her in Elder Scrolls Morrowind, as imagined by a fine tune that's been taught what QWERTY looks like, unlike other golden retrievers. And we got a ton of other stuff on there. We got protein folding. We've got sandboxing. This one's fun. This is an LLM coding agent that writes Hugging Face Transformers code, so runs its own language models. And then that code that it writes is run inside of a sandbox on Modal so that you know it's not going to steal your secrets or pseudo-RM RF and nuke your service or steal your lunch money. So that's another example. That was a fun one. We've got a RAG example. You got to have a RAG example. Yeah, it's all on there. And even if you're still, big data is still important, maybe even more important now that we've got language models and other things that can crunch it. We've also got things like this DuckDB on Parquet files from S3 scale out example. Not just GPUs, not just neural networks, but any data intensive workloads you want to run in the cloud. I think we can make them better, faster, stronger.
This is so cool. I love seeing DuckDB there. I love seeing Gradio flash up. Gradio is one of my favorite tools in the ecosystem for just quickly shipping products to share with friends and colleagues. Sent a Gradio app to a bunch of non-technical friends recently just to play around with language models and multimodal models. Charles, and
Hey,
QWERTY. Big
I
up,
have to
big up.
say, when I made this originally, before I joined Modal, when they released A100 GPUs, I like immediately went and made this fine tuning example, and it was Christmas-ish 2 years ago. Yeah, 2 years ago. And I gave it as Christmas gifts to the people. I would make one of these for their pets, and I would hand them this URL, and I'd be like, go and make pictures of your dog. Thanks for letting me crash on your couch. And that was like, somebody who was more of a researcher and an educator before, that was my like first taste of the joy of making something and being able to deploy something onto the internet for anyone to use. And that was what inspired me to eventually become a Modal developer advocate, because I want more people to experience that same joy.
Beautiful.